Now that we discuss a little bit review of logarithmic differentiation, logarithm rules and derivative of logarithm, now we want to go back and figure out a few things about logarithmic differentiation. So the first thing is this example. We are trying to find the derivative of f of x, that is x to power x. Look at this function. It's not a constant to a function, not a variable, or it's not a variable to a power, constant power. It's a variable to a variable power, and that's when we need the logarithmic differentiation. Otherwise, and if it was variable to a constant number, you would have the power rule. If it was a number to a variable, then you would have the exponential the rule to use. Here is the a variable to a variable, a power variable. And so what do? So let's start with here, y equal to x to power x. Then I say, well, I don't know how to do variable to variable, but I know a lot of rules with the derivatives. So the first thing that I think is that, what if I don't have the variable as the exponent? So I take the natural log of both sides. And what the natural log does is it does this beautiful thing for me, that is, it's going to make that exponent to come down. So this one's going to come down here. So I will get step 2. This was the first step. You take the natural log. Step 2, x, I used my logarithmic laws, and I do this. Then what would this step 3 be? It's still, I haven't taken a derivative yet. So the step 3 is usually taking the derivative of both sides of this thing. So you want to, for step 3, you want to take the derivative of both sides of this equation. So step 1 was taking the logarithm. Step 2 was simplifying it. Step 3 is taking the derivative of both sides. And so taking derivative of natural log of y, hold on, y is a function of x, and I can see it right here. It's actually x to power x. But I don't know the derivative of y. So when I'm trying to take the derivative of natural log of y, I'll take the derivative of the outside, and when I take the derivative of inside, I do it implicitly. So this would be 1 over y, and then dy dx, and then on derivative of this side, I see a product rule, and because it's x times natural log of x. Derivative of first one is 1 times the second one, plus the first one times the derivative of the second one. So what am I ending up here, if I simplify, is 1 over y times y prime is equal to natural log of x plus 1. Now, to completely solve this, remember, I am trying to find y prime. And to find y prime, I have to basically solve for y prime. One other thing, I want y prime as a function of x. So I have to replace 1 over y by the value that we had over here, y equal to x to power x. So this is going to give me, this would be the step 4, and it's going to give me, I want to solve and I'm replacing y by x to power x, and I'm getting a natural log of x plus 1. That is, the final answer is y prime is equal to x to power x natural log x plus 1. And that's the derivative of this function. So things that I want you to notice is that when we were taking the derivative, we were not using the power rule, or we weren't using the exponential rule. They did not apply for this function because, again, both exponent and the base are functions, non-constants, I'm sorry. So neither of those were working. Then the other things that to notice are the steps that we followed. We took the natural log of both sides and we simplified. We differentiate the expression implicitly and with respect to x. Then we solve for dy dx. And part of that solving was that to replace the values that we wanted to replace. See, again, what I wrote was you take the natural log, you simplify the side with the exponent, you take the derivative, and always the derivative on if it's y equal to a function of x, explicit function of x, you always get y prime over y equal to this derivative, and there will be a product rule on this side. And for if it's a function to a power function, not a non-constant to a power non-constant, you end up with a product rule. And then you solve for y prime, replacing y by what you began with, and that was that important part of it. And that gives you the answer to the derivative. And so, beside the steps that we followed, it's important to know there are generally 4 cases when you see exponents and bases. One case is the case that you have a constant and to power constant. A constant to a power constant, let's say 2 to power 3, it's going to be 8. And derivative of 8 is just 0. So a constant to a power constant is always 0. Derivative of it is 0. And then you can have a function to a constant. If you have a function to a constant, then it's a power rule. This one is a power rule. So that one was a constant rule. This one is a power rule. And so what do we do with power rule? You bring the power down, then you multiply by the function to power, this is a general power rule, to power 1 less, then you take the derivative of the inside. Now, what else can happen? The other way around. Oh, went too fast. The other way around is when you have a constant to a function, non-constant function. And so what happens then? This is the exponential rule. Exponential rule. And so how does the exponential rule work? You have you repeat the exponential, which is this part, and then there will be natural log of the base. If base is e, it's going to be 1, and then derivative of inside, which is g prime of x. So the case that we did right now is none of those. That case is this one. And so it's both the base and the exponents are both of them are functions, non-constant functions. And so this is how we describe that. And these are non-constant. When you see f of x and g of x, they're non-constant functions. And so how do we calculate that one? Using the logarithmic differentiation, is that there is a formula, and this is the formula for it. If you use the logarithmic differentiation, you get this formula. Would I recommend you to memorize the formula? Absolutely not, because it's the chances that you make mistake of memorizing the formula is greater, and then you will not get any points for the work that you haven't shown. But here's the formula for it if you want to use the formula. Okay, another place that we use logarithmic differentiation is when we have a lot of a function that is product of a bunch of functions. The example that we're giving in part 1 of example 2 is not too many products, but still it actually it pays off to learn it with fewer products and see how it works with more products with the same rule of it. So if I follow the same basic process that I did with the logarithmic differentiation when I had a non-constant to a power non-constant, and here, the first step that I want to take is to basically take the natural log of both sides. So I'm going to get natural log of y is equal to a natural log of 2x plus 1 to power 5. Oh, too many. Let's change this, and then x to the power 3 minus 1 to power 3. Now, when I'm taking the natural log, and the next step is always simplify this. And so natural log of y. This is a product, so I know the product becomes a sum, and exponents for each piece comes down. So I can write it that way. I can write 5 natural log of 2x plus 1 plus 3 natural log of x to the power 3 minus 1. It's important to notice that I cannot simplify this any further using the product rule, because there's no product or exponential inside, and as an exponential should be covering the entire thing. See, over here I did a power law first. That was natural log of it was natural log of 2x plus 1 to power 5 plus natural log of x to the 3 minus 1 to power 3, and then I did an exponential law, and it worked like that. And so now, so the first step is done, and it looks a lot simpler than we started. So what logarithm does, it's one of the properties of logarithm that is used a lot in math, is it takes the product and makes it into sums. And then taking derivative of both sides of this is gonna, again, on this side it gives me y prime divided by y. Here it's 5, which is the coefficient, and then derivative of natural log, it's going to be 1 over the inside times the derivative of inside. Oh, sorry, just x. And then plus 3 times, because 3 is the coefficient, 1 over derivative of 1 over inside times the derivative of inside again. And so we've done this, and then I have to solve for y prime, and solving for y prime will result in y times this entire thing. 2 times 5, 10 over 2x plus 1, plus we have a 3 over here times 3, 9x to the power 2 over x to the third minus 1. And then if I replace, if I want to replace y with what it was to begin with, let's get rid of the y over here and replace it with what it was, the function that it was. And I get the answer. So that's the function. And that's how we solve a derivative of product using the logarithmic differentiation. Again, logarithmic differentiation, another one of its usage is when you have exponents and products and quotient. And so here's another example of this. How do I solve the derivative of y when y is this quotient to a power? And so the first thing that we want to do is to take the natural log of both sides. What does the natural log of both sides give us? It gives us natural log of y is equal to pi times natural log of the numerator minus natural log of the denominator. Now, let's simplify this a little bit more. The natural log of y is going to be equal to pi times, use the product, 2 natural log of x plus natural log of x minus 1 minus 1/2 of natural log of x plus 1. Now, if I take the derivative of this side is y prime over y equal to pi. Derivative of the first term, 2 over x. Then the second one is 1 over x minus 1, but and times the derivative of inside, which is 1 over x minus 1. And then this term is negative 1/2 of natural log of x plus 1, which is 1 over x plus 1, times derivative of x plus 1, which is 1. Now, the last step is to solve. And when we're solving, we're multiplying this side by y. What is y? Y is x squared, x minus 1, divided by square root of x plus 1, the entire thing to power pi. And that's how we solve this one. So now that we're done with this question, let's start another question. Example 2, part 3, find the natural log of find the derivative of y if y is equal to x to power sine of x. So how do I do this? Again, it's a function to a power function, right? And neither of them are constant. So what I do is I take the natural log to make the function on the right side in the format that I actually can take the derivative of, and that is sine of x times ln of x. Take the derivative, the natural log of the right side, and you get the exponent comes down and it becomes a natural log of the base. Then the next step you want to do, so that was the first step. And the second step you want to do is you want to take the derivative. Again, left hand side becomes y prime divided by y. This is a recurring part. Again, this derivative of the outside is 1 over y. Derivative of inside is the y is, we're going to take the derivative of y implicitly and write it as y prime, and then we have the product rule over here. Again, if in this type of logarithmic differentiation, that's a recurring theme. And so in here, derivative of the first one, derivative of sine is cosine of x times natural log of x. Then you have sine of x times 1 over x. Now the last part is to solve for y prime. So y prime, I have to multiply both sides. Again, this is something that you see a lot, and I'm putting the entire thing in big parentheses so I remember that I'm multiplying everything by y. And then I multiply everything by y. But what was y? Y was just x to power sine of x. So that's the final answer in here. So let's do one more question in here. This time it's y equal to sine of x to power arc tan of x, and we're trying to take the derivative of this y. Again, a non-constant to power non-constant, and I don't have any formula from before, so I have to use, and I don't want to memorize the one that I gave you, so I have to do the logarithmic differentiation. Again, first step is to take the derivative of, natural log of both sides. And so you get natural log of y is equal to natural log of something to a power. Power comes down. And natural log of the base. And then when you're taking the derivative, which is step 2, you have to remember derivative of natural log of y is going to be derivative of outside, which is 1 over y, times the derivative of inside, which is implicitly dy dx, which is going to be y prime over y. Then you will have a product rule in here, and that would be arctan of x. Derivative of that we learned just recently is 1 over x squared plus 1, and times the second term then plus arc tan of x times the derivative of natural log of sine of x, which is going to be the inside in the bottom, then derivative of inside multiplied by derivative of inside. Now, the very last step is to solve for y prime, which is going to be y prime is equal to big parentheses, all you found, which is ln of sine of x divided by x squared plus 1 plus the arctan x cosine of x divided by sine of x multiplied by y, which is sine of x to arc tan of x. And so that's how we take the derivative in here. And so my handwriting was not the perfect one, so I'm going to show you the answer over here. And so when you're writing cosine of x over sine of x, it also goes as cotangent of x. And